Why is our society so obsessed with the concept of life on other planets?
Do you believe in UFOs?
Oh yeah, yes sir, definitely. They're out there, man. I've seen them. I've been out there in Aurora, Texas.
Today, we are not only actively looking for alien life, but are making this possibility a part of our modern culture in almost every conceivable way. What's interesting is that it hasn't always been this way. We as humans have always had an obsession with the unknown, but you won't find any cave paintings with little green men from other planets. No. This fascination only started to occur after we began to learn our true place within the cosmos. For ages, this was believed to be our universe, with everything in existence revolving around Earth and us as humans. God had put us on this planet because we were special. Then, over the years, some very smart people came along, like Copernicus and Galileo, and they said, no, everyone is wrong. We are in fact not the center of the universe, and all those stars that move in weird directions are not stars, but other planets. Just like this one. Suddenly, we started to feel a little less special on our little rock in space. But in a million ways, we still are an incredibly unique planet. We are the only known planet to have actual life exist. But if we've discovered that there are other planets, and other solar systems, and other galaxies, it becomes more and more unlikely that we are in fact that special. The only way that we can start to comprehend or predict life on other planets is if we look back to see how it developed on our own. That means we have to go way, way, way back 4.6 billion years ago to a lifeless rock that we now know as our Earth. The Earth was a very different place at this time. In this age of creation, constant bombardment from extraterrestrial objects kept the planet in a fiery volcanic hellscape. Any water that existed here was in the form of hot steam in our atmosphere. But as the solar system started to settle, so did the temperature. This brings us to the first thing that we have deemed necessary for carbon-based life as we know it. As Earth fell into its resting temperature, the water in our atmosphere started to rain down on the still young planet until the whole thing was basically covered in water. This was only allowed to happen because of our positioning in relation to the Sun. We call this nice spot in our solar system the Goldilocks Zone. Yes, after the nursery rhyme with the 3 bears. If we were too close to the Sun, the water would stay in our atmosphere as steam. Too far away, and the water would freeze. Our home is that perfect bowl of porridge to allow liquid water and subsequently life to thrive. Great, so now we have a planet that is covered with water. But here's where things get a little complicated and a little blurry. Right now, we are able to prove and observe that life as we know it is just a series of complex chemical reactions working together. At its very beginning, this was taken to its most simple form. In the mineral-heavy oceans of this young Earth, there was a spark of life. Carbon atoms started working together to absorb the chemical soup at the bottom of the ocean. These microscopic specks have the ability to reproduce, and because of that, it leads to imperfections and mutations. Some of these mutations allow the specks to survive longer, and then those that survive the best can create new things that survive even longer. Now imagine repeating this process for billions and billions of years. Suddenly, these specks have to deal with eating different things and even each other, prompting even more diversification. Only the strongest survive and pass on their advantageous traits to even stronger life forms. Life begins to get more and more complex, better and better at surviving, and ages later, we get to this point, where life exists in mind-boggling diversity. Feel good right now, because you are the current peak of complexity known in the universe. The ability to even comprehend what I'm saying is the result of 3.7 billion years of trial and error. Okay, now that you have that confidence boost, let's not forget about the amazing factors that could even allow this to happen in the first place. Our place in relation to the Sun, the size of our planet, our stable shell of an atmosphere, our perfect-sized moon, and even Jupiter acting as a vacuum for any stray outer planetary objects that could, wipe out all of life on Earth. These set of traits may seem incredibly coincidental, but that's just the nature of our universe. With over 100 billion planets in the Milky Way galaxy alone, it was almost guaranteed to occur somewhere. But that also means that it's almost guaranteed to have happened somewhere else too. So with our current understanding of the universe, given enough time and a suitable environment, life can and probably has developed on other planets. Whether evolution will give rise to intelligent technological civilizations is open to speculation. But if they are out there, the first step is to look. But where do we even start in a search like this? You probably don't need to be told that the universe is incomprehensibly massive, and finding that needle in the interstellar haystack is no easy task. Well, the best thing we can do now is narrow down our options by looking at the factors that led to life on Earth and finding that specific criteria elsewhere in the universe. The tricky part is, we don't know exactly how life could have developed on an alien planet.
Who knows, dude? They could be made of water. I don't even know.
Water?
Water, man. You heard the man. Water.
We are really just making assumptions based on the fact that Earth is our only real example of a planet capable of sustaining life in the first place. And finding similar exoplanets is our best foot forward in this search. In 2009, NASA launched the Kepler Space Telescope, specifically designed to look for alien planets and those with Earth-like qualities, including size, density, and if they are located within the Goldilocks Zone. Unlike most other telescopes, the goal isn't to view these objects, but rather to collect data. Whenever a planet orbits around its star, it creates a shadow and blocks some of the light that is able to reach the telescope. Kepler is built to detect these small differences and accurately identify its distance and size in relation to its star. As of now, we have been able to identify dozens of exoplanets that share enough in common with Earth to be potentially habitable. Earth in size and composition is a very typical planet, and there are likely billions of others in the Milky Way galaxy alone that have yet to be discovered. But here is where the sheer size of the universe starts to create some problems. With our current technology and speed and fuel, there is no plausible way that we would ever be able to reach those planets. Although for us this may be nearly impossible, for future generations and potentially even more technologically advanced beings, this is entirely in the realms of possibility. Although we may not be able to reach other planets outside of our solar system in our lifetime, it doesn't mean that contact with alien life is impossible. In fact, we probably won't be the ones looking anytime soon. Right now, the best we can do is simply sit back and listen. Seti is an institute that was put together in the 1960s that stands for Search for Extraterrestrial Intelligence. The organization uses massive array satellites in an attempt to pick up any signals from any potentially advanced alien civilization emitting them. Just like any other satellite, its goal is to pick up wavelengths and convert them into usable data. The hope is that one day we get something abnormal, something that could only be created by another advanced civilization. And Seti isn't the only company trying to do this. You have dedicated people all over the world that are listening and waiting. And so far, we have detected nothing. Right now, there is absolutely no solid proof that alien life of any kind is, has, or ever will exist. Despite our effort, we are, as we always have been, completely alone. But mathematically, this doesn't really make sense. There are an estimated 11 billion Earth-sized planets orbiting in habitable zones around our Milky Way galaxy alone. Let's just say that 0.01% of those actually developed life at some point in their ages of existence. Then, there should be millions of individual planets with aliens of some kind. Let's just say that a small handful of those life forms actually have a chance to evolve freely and grow to create technology. Eventually, they would reach a point that we are getting scarily close to. We know that interstellar travel and colonization of other planets is possible, and given the rate of expansion and the time that it takes to reach other planets, the entire Milky Way galaxy could be covered with life in just 100 million years. Compared to the 13 billion years that the universe has been around and the countless opportunities for this to happen, it begs the question, where is everyone? The probability is heavily in favor of us being able to observe some kind of intelligent life, but so far, we are alone. This conundrum is known as the Fermi Paradox, and it has been the subject of debate for many people in the scientific community. Maybe we're just not looking properly, or haven't been around long enough to observe anything. Maybe there's a limit to technology, or civilizations destroy each other before they can even expand. Maybe, just maybe, there's a galactic superpower set to control the disease of life in our universe, or we are all really just living in a simulation and alien life simply hasn't been programmed yet. Or maybe, the saddest of all, what if we really are just alone? An anomaly, a speck of consciousness in a dead, lifeless universe. Whatever the answer is, it doesn't change the fact that for now, we are a lonely planet. But what if it's better for us to keep it this way for as long as we possibly can, or even forever? If we look back at our own history and see what happens when two separate cultures meet for the first time, it almost never ends in anything but violence or hardship. It isn't always direct, like war, slavery, or slaughter, but when the Europeans arrived in North America for the first time, the natives had never experienced smallpox, measles, or the flu before, and the viruses tore through the continent, killing an estimated 90% of Native Americans. At the time, it didn't matter too much to the Europeans. Most of them didn't have malicious intent, but they were here to improve life for themselves and for their country back home, no matter whose land or whose life got in the way. The truth is, we don't know what could be out there, or what other life could even want from us. But why would we even want to take the risk? We may never truly know if life exists elsewhere in the universe. But if the extraterrestrial phone ever does ring, it's in humanity's best interest not to pick it up.